6.4 part 2. Okay, if we're looking to figure out if things are inverse functions of each other, okay, right here, these two charts right here, the graphs of the power functions f of x equals x squared and g of x equals x cubed. So f of x equals x squared is in black, g of x equals x cubed is in black. Those are the parent functions of those graphs, okay, are shown below, along with the reflection in the line y equals x. So, do you see this dashed line?
Yeah.
That's a reflection line of y equals x. When y equals x, I have a reflection line that's diagonal through the origin, okay? Notice that the inverse of g of x equals x cubed is a function, but the inverse of f of x equals x squared is not a function. Here's how you do that. Here's how we decipher this, okay? We're going to figure out by using a horizontal line test, okay? So this is a function here because the function, the inverse function of g of x equals the cube root of x. Okay, I can create my function. When I switch x and y and resolve for y, okay, or switch x and y in this case, I get x equals y squared. Okay, this is not a function. We're going to discuss that a little bit more in depth in a second, why that's not a function. But first, we're going to find the inverse of f of x equals x squared with the parameter of x is greater than or equal to 0. Then we're going to graph f and the inverse of f on the same graph. Okay? So, if I want to find this stuff, we're going to talk about how that works. Because on this, do you see how this has a parameter of x is greater than or equal to 0?
Yeah.
Does this have a parameter with it?
No.
No. That's why when I do the inverse of this, it's not a function, okay? Because here's the deal. The domain of f of x equals x squared is restricted to only non-negative numbers, right? I cannot take the square root of a negative number and get something out, yes? So when I switch it this way, do you see how this graph goes into the negative side? That means I do not have a function because I can't have negative square roots. So when I use a parameter on it, such as x has to be greater than or equal to 0, that means I'm only going to graph one segment of this parabola, which then allows that to be an inverse function, okay, when I take it a segment at a time. So if I want to graph f of x equals x squared, okay, it says find the inverse of that. So if I want to find the inverse of f of x equals x squared, what do I do to find the inverse first? What do you do to find the inverse first?
Oh, that, you switch.
Yeah, switch x and y, right? Y is technically here, so you get x equals y squared. I want to resolve for y, so how do I do that?
Wouldn't you divide?
What?
Oh, subtract.
No, there's nothing to subtract or divide. What's happening to y right now?
It's squared.
It's squared, so how do you get rid of that?
Oh, root.
Yes, take the square root. So, root it. Y equals the square root plus or minus the square root of x, right?
Yes.
Okay, so this is now my inverse function. Okay, now that I know my inverse function, I can then start to graph both of these things. Okay, we know that the domain of f is restricted to non-negative values of x. So the range of the inverse of f must also be restricted to non-negative values. If this is a restriction for the function, then that also has to be a restriction for the inverse function. Does that make sense what I'm saying? So I'm working with graphing this equation here along with this equation here. So let's graph the top one in green. If I graph f of x equals x squared in green, but I know my x has to be greater than or equal to 0, what type of numbers can I plug in?
You could plug in all real numbers or all positive.
Yes, all positive real numbers. I'm going to count by 2's here. So let's plug in numbers that we know come out nicely. What's 2 squared. If I plug in a 2, I get a
4.
4 out. So 2 and 4. If I plug a 4 in, what do I get out?
16.
A 16. So 4, 2, 4, 6, 8, 10, 12, 14, 16. Okay. So I have a graph that's going up like that. Okay. And my original starting spot would have been 0, 0, right? Because if you plug a 0, you get a 0. So I am only graphing this segment of my parabola. Do you see that? Okay. Now, the inverse function, I'm going to come over here and graph it in black. Okay. Is still got a restriction of x has to be greater than or equal to 0, yes? So let's plug numbers in that we know have a perfect square. Okay. So what has a perfect square that we can plug into x?
4.
4. So what's the square root of 4?
2.
Plus or minus 2. Okay. So if I do this, okay, and I count my 2's here as well, -2. Okay, plus or minus 2. But remember that x has to be greater than or equal to 0, right?
Yes.
So I'm not going to take the negative output, I'm only going to take the positive output because I want everything to be a reflection of what's over here. So if I plug in 4, I get a 2 out. If you plug in 16, what do you get out?
4.
Okay, 4. So 2, 4, 6, 8, 10, 12, 14, 16, and 4. Okay, and when I plug in 0, I get 0, 0, right? Do you see how this, if I drew a line of y equals x through there, is symmetrical? This point reflects over that line to here. This point reflects over that line to here. This point falls on that line, which is why it stays the same. So you're reflecting portions of this graph. That's why I can only choose the positive output, because if I had the negative output over here, I would reflect the negative down here, and that doesn't work because I can't have negative because of my parameter.
So it goes with that restriction?
Yes.
Okay.
And the only reason I put a restriction on it is because if I don't, this isn't an inverse, the inverse function isn't a function, okay? It's just an inverse equation. Here's how you can tell if something has an inverse function or not. You do a horizontal line test. Remember vertical line test to tell if it's, what am I trying to say? To tell if it is a function. To tell if the inverse is a function, you do a horizontal line test. If, when you draw a horizontal line anywhere through the graph, it only goes through the graph once, it's a function. If it goes through the graph twice, it's not a function. So when I draw a horizontal line through the original parabola, the original f of x equals x squared, when I draw that line through there, it goes through twice, which means this graph here is not a function. The inverse is not a function. Okay? When I draw a horizontal line through this original equation of g of x equals x cubed, it only goes through once, which means that the new inverse function, or the inverse, is a function. Okay? So, with that being said, we're going to graph a function. It says consider f of x equals 2x cubed plus 1. Determine whether the inverse of f is a function, then find the inverse. To determine if it's a function, I have to graph, to determine if the inverse is a function, I have to graph the original function, do a horizontal line test, and then I can say, yes, it's a function, no, it's not a function. Then I can find the inverse anyhow, okay? So, how do you think I'm going to graph f of x equals 2x cubed plus 1? What do you think I need to do?
Don't you need to find the inverse first?
No. Because we don't, it says determine whether the inverse of f is a function. That's what we're doing first.
And then plug in points.
Just plug in points. I'm going to plug in negatives, positives, and 0, okay? So I'm going to plug in probably -2, actually let's do this. Let's do -4, -2, 0, +2, and 4, okay? Just so I can get a wider range of stuff. If I plug -4 into x cubed, what do you get when you plug -4 into x cubed?
Negative 64.
And then times it by 2, and then add 1 to it.
Negative 127.
Beautiful. When you plug in negative 2 cubed is
Negative 8.
times 2
Negative 16.
plus 1.
Negative 15.
Negative 18. 0 into this gives you 1, right?
Yes.
So then 2 and 2 plus 1 is 3. 2 cubed gives you 8, right? 8 times 2 is 16. This should be 17, not 18. And 16 plus 1 is 17. 4 cubed is, what did we say it was again? 64. 64 times 2 plus 1 gives me 129. This should be negative 129. You added, oh no, wait.
Wait, so they're parallel?
No, let me check this again. I could have lied to you. Negative 4 cubed times 2. Okay, this is 127. And then negative 2 cubed times 2 plus 1. This is negative 15. We had it wrong in the first book. Negative 15. Okay. So I get this. So if I make a rough sketch of this, because clearly I don't have massive numbers, negative 4 is down here with negative 127, right? Okay, negative 2 is at like negative 15. Let's just pretend it's here. 0 is at positive 3. 2 is at like 17. And 4 is at like 129. Okay, so my graph goes like this. And we want to just make a rough sketch of it because what we're really trying to ultimately do is the horizontal line test on this. So I graph that roughly. I do a horizontal line test. Will the inverse be a function?
Yes.
Why?
Because it goes through 1.
Okay, so the inverse is a function. Now, they want me to find what that inverse is. So how do I find the inverse? What do I do? Step 2, find the inverse. What do I do for finding the inverse?
You have y equals 2x cubed plus 1.
Yes, y, no, not, well, this is how the original equation starts. Yes, if I replace the f of x with y. Now what do I do?
You would do 2x, no, x.
No. I replaced f of x with y.
Yes.
So what do you have to do to find the inverse? You have to first flip x and y. I still have to flip them. Just because you plugged y in doesn't mean you flipped it. So I flip x and y so that x equals 2y cubed plus 1. Now, I need to get y by itself. What do I do?
Would you just divide by... we said you need to get y by itself.
Yep. So what do you want to do first?
You just divide
You would divide
by 2.
I want to divide by 2 first. I would do something else first.
Oh, subtract.
Subtract 1. Yeah.
Oh,
It'll make it easier. So x minus 1 equals 2y cubed. Now what do you do?
Divide by 2.
Divide by 2. So then
so
you
even
get...
if it does have the
Yeah, it will
cube,
just... Yeah.
you still would divide.
Now what do you do?
Take the cube.
Yes, take the cube root. So then the cube root of x minus 1 over 2 equals y. So your inverse function, yes, equals the cube root of x minus 1 over 2. And that's what they want you to do on this. You have to graph the original equation to see if the inverse is a function. And whether it's a function or not, you're still giving me the inverse
Okay.
function.
That was my next question.
Whether it's a function or not, you're still giving me the inverse function. Okay? Those are the things you are doing today. You're going to graph the regular function and an inverse together. And then you're going to determine if something's an inverse by graphing the original function first, doing a horizontal line test, telling me yes or no, and then still coming up with the inverse function by switching x and y like we did last night and resolving for y. Okay? That's the second part of this.